Our next speakers are Luca Lepew, Strikwerda from University of Groningen, and their talk is entitled iRODS Monitoring for System Administration.
Thank you for having us here. It's a great opportunity to be here. Our talk will be about the iRODS monitoring we do in Groningen. We created our own scripts to do the monitoring of the application and also the monitoring of the system. We do this from the Research Data Management System in Groningen. So first, small introduction about the university in Groningen. It's also very old, similar to Utrecht. It's 400 years old. It has 30,000-ish students, 9,000 internationals. It does research in energy, health and aging, sustainability, society, and astronomy. And it's home of the Nobel Prize winners Frits Zennike in 1953 and Ben Veringa in 2016. Groningen is in the north part of the Netherlands. It's about 300 kilometers from Amsterdam to the north. We work at the CIT, which is like the central IT department. It's also pretty old. It started as the Rekencentrum in 1953. It had its first computer. It's called the Zebra, the zeer eenvoudig binair rekenapparaat. It means the very simple binary calculation system. It now runs at 270 employees in 3 different domains, and we are running in domain research. We do high performance computing and data management. We do this inside the team RDMS. It's also very old. We started in 2016 as iRODS community member, and we do the long-term data storage for researchers, up to 10 years of data storage. And we do this as a service. The data is replicated in 2 different data centers across the town, one in the north, Zennike, and one on the southeast in Amersfoort. And the goal of 2026 is to do the data archive via SURF to do some movement of all data to tape. We have about 1,400 users, and we store up to like 1.5 petabytes of data. Times 2 is 3 petabytes of data replicated. This is our setup. The users can connect via the university network or remotely via the VPN. We have an interface of RDMS web frontend, the WebDAV functionality from DAVRODS from Utrecht, and also, of course, the iRODS command line clients used by Linux and high-performance computing people. We have 2 zones, a normal zone for the normal people and a special zone for the special people, the sensitive data. The storage is done via NFS, and also the replication is done via NFS in 2 different data centers. But on topic, we talk about system monitoring. We have 2 options. We monitor via Nagios or Negaos, or how you pronounce it. And we also have this iRODS Prometheus exporter created by Luca. And it has a combination of system and application monitoring. Nagios or Negaos is a bit old school. It's a cron-tab fired check script, so it's not really real time. It checks every 10 minutes. It checks, for example, the version, if the service is running, if the system has a heartbeat, like the iRODS system is really responding. And it also displays the stale delay server rules. And perhaps we can add some other checks. The script is created by John McFarland, who's an application manager of iRODS. And here you can see an example. You can see the iRODS is active, the daemon is active, the heartbeat is going on, and the delay queue is at 0, which is nice. Why do we have Nagios and Prometheus? We have both, because Nagios can be good at sending warnings and triggers to me, like via email, but it does not have any trends or graphics. And Prometheus is really cool in dashboarding and fancy graphs, and you can have longer time trends. And it's a good way to correlate the relationship between the application and the system. I'm not going to talk about Grafana that much or Prometheus, but there are some concepts. You have this exporter running on a system that exports the metrics via HTTP. The Prometheus scrapes the metrics and saves it in a database. The alert manager that can create and set triggers to alert. Grafana can read the metrics, and Grafana can show the metrics via the web dashboards, which you can rate yourself. In the picture, it looks like this. We have different resources, ICAD, resource server, and Kubernetes, for example. They all run different kinds of exporters. We have the Node exporter that does the system stuff like CPU and memory and stuff like that, but also the iRODS exporter created by Luca. and a storage exporter created by myself that checks the mount points and checks how much it's full or it's responding. And Kubernetes, we have the RabbitMQ exporter by Venus, for example. Prometheus is scraping all those metrics, saves it in a database, and Grafana is able to read the database. And on the top here, on the left, on the right corner, that's me, the sysadmin, looking at the graphics. And from here, Luca is going to explain about his iRODS Prometheus exporter.
So thank you, Ger. So we wanted to, as our proof of concept, we decided to make this iRODS Prometheus exporter, which we try to make as a Python-based lightweight utility. And we wanted it to be reusable and adjustable to our specific deployments, because as Ger mentioned, we have different zones with different configurations and different loads. And the utility runs as a service account on each iRODS instance and collects metrics using iCommands, and then publishes them as a Prometheus compliant interface. Now, what are we collecting? Could you go to the next slide, please? Thank you. So, besides the basic service information that we collect, like the reported uptime, the iRODS version, and some very simple benchmarks that we've written based on iQuest and ILS, because the RDMS greatly relies on the delayed rules for users' background operations, we mainly focused our initial efforts on monitoring the delayed rules queue, as well as the client processes, which are the active connections to iRODS. So using these metrics, what can we do? Could you go to the next slide, please? So here you can see, for example, in this visualization of the delayed queue in Grafana, which shows the the upload of data objects to one of these zones, and it shows the graph shows the profile of the rules being queued for delayed checksumming, as well as the rate of the checksums being processed. And this is a nice visualization of this, and it makes clear how the system is behaving in this scenario. Next slide, please. But also, here is another situation still based on the delayed queue. We have had issues with the delayed server stop processing the queue. And in this case, you can clearly see when the queue stopped, as well as the content of the queue at the moment of the breakdown. For instance, the type of the priority of the queues of the rules that were queued in that moment. And this is useful to try to see some patterns in the type of situations where the queue was breaking, the delayed server would stop processing the queue in our case. Next slide. Another thing that we can see, as I mentioned, is the client processes that are connected to our iRODS systems. And in this case, you can see a breakdown of the client processes based on username, client type, and the origin, which allows us to see also how long each connection lasted. For instance, we have a connection from our web client, and those are more persistent connections, and that are still greatly based on jargon. So we are moving away from it, but you can see that that's the most of the connections in this moment to the system. And also they are the connections that lasted the longest. Another thing that you may notice on this is that we try to anonymize the usernames and the origins, because they are in plain text in IPS, whereas here we just need to have a data point effectively. Next slide, please. So, but what is I should say, more useful feature of these metrics is the fact that we can, as Ger mentioned earlier, combine them with other sources. For instance, we can combine these application level metrics that we collect from iRODS with more traditional CPUs, memory, and network loads based metrics. And this will allow us to correlate iRODS activity, like in this case of the case of the delayed server or the client processes, with the system loads, and that can be useful, or we found it useful also for quick diagnosis or to try to attribute a malfunction to one specific activity. Next slide, please. So this is what we have at the moment. What are we planning for the future is that we would like to extend this utility with more metrics, for instance, more metrics based on the delayed queue. We would like to monitor the repeating rules, as well as monitor the expected execution time for the rules, which should allow us to have a better understanding on the what we call stale rules, the rules that are staying in the queue but are expected to be already been processed, which we may use as a way to write an alert or a possible indication of the slowness of the delayed server. But we also would like to extend it with other simple benchmarks based on iPut and iGet to get some consistent benchmarks on to try to detect specific slowdowns of these operations in a more finite grain, let's put it this way. But finally, we would like to then make this tool open source. But before we do this, we would like to move away from the iCommands collection and try to rewrite some of these metrics using the Python iRODS client for more reliable and more maintainable code. But yeah, I think this is what we have at the moment. Thank you.
This is the end of our presentation.
So we have an extra slide for questions.
Yeah. Do we have any questions?
Hello. Do you have a way to make alerts for the storage, for example, something that is hard to make sure that it's working, like archive?
So for the alerting in Prometheus, we have this alert manager, and the alert manager is able to check the metrics of the storage exporter. So for example, if the mount point is not responding, then the alert manager can send messages to me via a Slack channel. So I can see that something is going wrong with the mount point. Like the mount is slow or it's not responding. It gets done via the alert manager. Yeah.
And is it effective, or you might have like...
It really depends on the time. For example, if the mount point is not behaving at 4 o'clock in the morning, I'm still sleeping, so I can't respond. But if it's doing that at 10 o'clock in the morning, I can respond faster. So it really depends on the manpower, of course. Yeah. In the end, somebody has to fix it. Yeah. We don't have these robots. It's still me. So yeah.
Any other questions? Yeah. All right. Thank you.